Okay. Okay. Good afternoon, students. So please respond. Voice is clear. Board is visible or not? So please respond. 7 members. Okay. So next question. Next long answer right out. Second long answer. Stationary waves. How are stationary waves? How are stationary waves formed in closed pipes? How are stationary waves formed in closed pipes? How are stationary waves formed in closed pipe? How are stationary waves formed in closed pipes? Explain the various modes of 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 vibrations. Explain the various modes of vibrations. Explain the various modes of vibrations and obtain relations for their frequencies. And obtain and obtain and obtain relations for their frequencies. Okay, now, so very important question. So explain the formation of stationary waves in a closed pipe, and finally you have to derive the frequencies. Okay, now, so first, how to define closed pipe? Closed pipe is nothing but what here? A pipe which is closed at one end called closed pipe. So this is nothing but what here? Closed pipe. One side open and another side is closed. Then that is nothing but what here? Closed pipe. So this pipe consists of air column. This is nothing but what here? Empty space. Okay now. So in this gap, air column is. Okay now. So this closed pipe contains air column. Right. So next one is nothing but what here? Formation of stationary waves in a closed pipe. How stationary waves are formed in closed pipe. Okay now. So in that situation, what happened? Basically, this is especially this is closed pipe. In this closed pipe, air column is there. Okay now. Now whenever that air column is vibrated or whenever a sound wave is passing through that closed pipe, in that situation, what happened? When a sound wave is into a closed pipe, then what happened? The wave gets reflected. Whenever a sound wave is sent into this closed pipe, what happened? The air column will vibrate. So in that situation, what happened? The wave gets reflected at the other ends of the pipe. The wave gets reflected at the other ends of the pipe. Now, second one is nothing but what here? The incident wave and reflected wave. First incident wave, then reflected wave. Both are in having same frequency and amplitude. Both waves are having same frequency and amplitude traveling in opposite direction. So first wave is traveling in this direction, gets reflected at this point. What happened? Moving in opposite direction. So incident wave and reflected wave both are having same frequency and amplitude. Amplitude is nothing but what here? Maximum displacement. Okay, na? So incident wave and reflected wave both are having same frequency and amplitude traveling in opposite direction. Incident wave in this direction, reflected wave in this direction. So both are in opposite direction having same frequency and amplitude superimposed with each other. Superimpose with each other along the length of the pipe. Superimpose with each other along the length of the pipe and produces stationary waves. In stationary waves, what happen? Nodes and antinodes are formed. For example, one wave is traveling in this direction. One wave is traveling in this direction. For example, one wave is traveling in this direction. One wave is traveling in this direction. This is nothing but what here? Transverse progressive wave. Okay, suppose one more wave is traveling in opposite direction. One wave is traveling along positive x-axis. One more wave is traveling along negative x-axis, but both are having same frequency and amplitude. So, two transverse progressive waves having same frequency and amplitude moving in opposite direction superimposed with each other. Superimposed is nothing but what here? One more wave I am taking like this, opposite direction. So in that situation, what happens? Superimpose with each other along a straight line. In that situation, what happens? Stationary waves are formed. So stationary wave consists of loops. Okay, now in the situation where the two waves will meet, at that point, what happens? Nodes are formed. Here node is there, here node is there, here node is there, here node is there, here node is there. Where the two waves will meet, at that point, resultant displacement is equal to 0. At that point, node is formed. Antinode is nothing but what here? From here to here, maximum displacement is there. So this gap is nothing but what here? Antinode. At antinode, what happens? Displacement becomes maximum. So here also we'll get antinode, here antinode, here antinode. So finally, what happens? How stationary waves are produced? Whenever two transverse progressive waves having same frequency and amplitude traveling in opposite direction superimpose with each other, the final wave containing with loops, then that wave is called nothing but what here? Stationary wave. In stationary wave, what happens? Nodes and antinodes are formed. Remember this, one wave is traveling in this direction towards positive x-axis. One more wave is traveling in opposite direction along negative x-axis having same frequency and amplitude superimposed with each other. So what happened? The resultant wave containing with loops, then that wave is called nothing but what here? Stationary wave. In stationary wave, nodes and antinodes are formed. At node, what happened? Displacement is equal to 0. At antinode, displacement becomes maximum. Remember this. In case of stationary wave, nodes and antinodes are formed. At the node, displacement is equal to 0. At antinode, displacement becomes maximum. Okay, now from this diagram, wavelength. Wavelength is nothing but what here? Actually, from here to here, this is nothing but what here? Complete wave. From here to here, this is nothing but what? A complete wave. Lambda is nothing but what here? Wavelength of the one wave. One wave is nothing but what here? Starting from this point and here. This is ending. This is nothing but what here? Complete wave. Complete wave. This is nothing but what here? Wavelength lambda. From here to here, distance traveled by the wave is nothing but what here? Wavelength. Okay, na? So time period is nothing but what here? From here to here, time period is nothing but what here? Capital T. Time taken to complete one wave. Wave is nothing but what here? From here to here, this is a complete wave. From here to here. Time taken from here to here is nothing but what here? Time period, capital T. Time taken to complete one wave is called nothing but what here? Time period. Okay. So lambda is nothing but what here? Wavelength of the wave, and T is nothing but what here? Time period. Right? Now in this situation, you have to observe this point from here to here. From here to here. In this situation, what happened here? Node is there, here also node is there. So node to this node, distance how much here? Wavelength lambda is. Node to node. Okay, na? From here to here, distance how much here? Lambda is there. So according to this diagram, here node is there, again here successive node is there. Successive node from here to here. From here to here, distance how much? Half of this. From here to here, lambda is there. Again, from here to here, this is nothing but what here? Half of this lambda. That means node 2 succeeding node is nothing but what here? Node to node distance, how much here? Node to node distance. From here to here, lambda. From here to here, half of this wavelength. So the distance between node to succeeding node is equal to how much? Lambda by node to node distance is equal to how much here? Lambda by 2. Again, node to antinode or antinode to node distance how much here? From here to here. From here to here, this is nothing but what here? Lambda by 2. From here to here, lambda. From here to here, lambda by 2. Again, from node to node to antinode. From here to here, distance how much here? Half of this. Okay, na? So node to antinode or antinode to node, both are same. Node to antinode or antinode to node distance how much here? Half of this. From here to here, lambda by 2. Again, from here to here, lambda by 4. Remember these 2 points. Okay, now in case of stationary wave, the distance between node and succeeding node is nothing but what here? Lambda by 2. The distance between node and antinode is lambda by 4. Node to node or antinode to antinode, lambda by 2. But node to antinode or antinode to node distance is equal to how much? Lambda by 4. Remember this. Okay, na? Endukante ee concept use chestam next na. Okay, na? So here, how to define closed pipe? A pipe which is closed at one end called closed pipe. It consists of air column. So whenever a sound wave is sent into this closed pipe, what happens? The wave gets reflected at the other end of the pipe, and the incident wave and reflected wave, which are having same frequency and amplitude, traveling in opposite direction, superimposed with each other along the length of the pipe, and finally what happens? Produces stationary waves. This point compulsory rarely. Last 1 mark question. Okay, na? Now we'll discuss frequencies. Fundamental frequency, third harmonic, fifth harmonic, we'll get. Okay, na? One by one discuss it. So first, it has send me. No need of this diagram. Just closed pipe definition, formation of stationary waves in closed loop. Only 9 members ఉన్నారంట ఇంకా జాయిన్ గారా మీరు? Forty members ఉన్నారు SM2 వాళ్ళు. ఓన్లీ 10 members ఆన్లైన్లో ఉన్నారు. సో ఈ మ్యాటర్ కంపల్సరీ రాయాలి నేను. ఓకేనా? Why? Because formation of stationary waves in a closed loop. How stationary waves are formed in closed loop? So remember that node to node, lambda by 2. Node to antinode, lambda by 4. ఇది కూడా మీకు మెటీరియల్లో కొంచెం కాంప్లికేటెడ్గా ఉంటుంది, బట్ మనం డిస్కస్ చేసేది ఈజీగా ఉంటుంది. జస్ట్ ఒక 10 minutes ఫోకస్ చేసి ఆన్సర్ వచ్చేస్తుంది. మెటీరియల్లో కొంచెం కాంప్లికేటెడ్గా ఇచ్చాడు. సరే నిన్న లాంగ్ ఆన్సర్ కూడా ఓన్లీ ఒక 10 మెంబర్స్ రాసి పంపించారు. వాట్సాప్లో పెట్టమని చెప్పాను. ఓన్లీ ఒక 10 మెంబర్స్ రెస్పాండ్ అయ్యారు. మిగతా వాళ్ళు ఏం చేస్తున్నారు? ఓకే, సో నెక్స్ట్ వచ్చేసి విల్ డిస్కస్ అబౌట్ ఫ్రీక్వెన్సీస్. సో పుట్స్ heading fundamental frequency. Fundamental frequency. First one, fundamental frequency or first harmonic indicated with the small f. Fundamental frequency or first harmonic. So when we will get, in case of closed pipe, what conditions we will get fundamental frequency? Okay, so diagram compulsory. So here I am taking a closed pipe having a length L. Okay, na? So in this situation, what happened? Whenever a sound wave is sent into this pipe, what happened? The air column will vibrate. Then stationary waves are produced. Okay, na? So suppose in this arrangement. Okay, na? So first wave is traveling in this direction, incident on that closed end, and gets reflected. In this situation, at open end, we will get antinode. Here displacement becomes maximum. So at this point, what happens? Antinode is formed. Where the two waves will meet, then that is nothing but what here? Node. So at open end, always antinode is formed. At the closed end, always node is formed. Now in this situation, what happens? If the air column in this pipe, at least vibrating with at least one antinode and one node. If the air column in this closed pipe vibrating with at least one antinode and one node, then that air column is called nothing but what here? Fundamental frequency. So in this arrangement, what happens? Whenever the sound wave is sent into this pipe, the air column will vibrate, then stationary waves are formed. But especially if the air column is vibrating with at least one antinode and at least one node, then the frequency of the air column is called nothing but what here? Fundamental frequency or first harmonic. Okay, so here I am writing statement. If the air column in the closed pipe, vibrating with at least one antinode and one node. Okay, now if the air column in the closed pipe vibrating with at least one antinode and how many nodes are there here? One node is there, one antinode is. So if the air column is vibrating with at least one antinode and one node, then the frequency of the air column is then the frequency of air column. Then the frequency of the air column is called fundamental frequency or first harmonic. Suppose if the air column in that closed pipe vibrating with at least one antinode and one node, then the frequency of the air column is called as fundamental frequency. Statement trial compulsory. How many nodes and how many antinodes are? One node and one antinode for fundamental frequency. Now in this situation, suppose if lambda 1 is nothing but what here? Wavelength. Lambda 1 is nothing but what here? Wavelength of this wave. Lambda 1 is wavelength of the wave. If lambda 1 is wavelength of the wave in this situation. In case of fundamental mode, lambda 1 is nothing but what here? Wavelength of the wave. Then length of the pipe is equal to how much? Length of the pipe L is equal to. In this situation, what happens? Stationary waves are formed. So here lambda 1 is nothing but what here I am taking wavelength of that wave. In that situation, length of the pipe is equal to how much? From here to here, length is equal to how much? So here antinode is there, here node is there. So length of the pipe L is equal to distance between antinode and node. So antinode to node or node to antinode distance is nothing but what here? Half of the wavelength. Okay, na? Therefore L is equal to how much here? Lambda by 2, but here I am taking lambda 1. So lambda 1 by 4. Lambda 1 by 4. Antinode to node distance how much? Antinode to node distance is nothing but what here? Lambda by 4. But node to node distance lambda by 2. So antinode to node or node to antinode distance is nothing but what here? Lambda by 4. Therefore L is equal to how much here? Lambda 1 by 4. Lambda 1 by 4. From this equation, lambda 1 is equal to how much? Wavelength of this wave is equal to how much? In case of fundamental mode, wavelength of the wave is equal to how much? Lambda 1 is equal to 4 into L. Remember this. Confused. If the air column in the closed pipe vibrating with at least one antinode and one node, then the frequency of the air column is called as fundamental frequency. If lambda 1 is the wavelength of the wave in case of fundamental mode, then length of the pipe means what here? From here to here distance. So antinode to node distance lambda by 4. Therefore L is equal to lambda 1 by 4. Therefore lambda 1 is equal to how much? 4 into, right? Okay. So next one, we know that one relation, but we know that what is the relation between V versus N versus lambda? V is equal to N lambda. V is equal to N lambda. Relation between velocity of sound in air versus frequency versus lambda. So here V is nothing but what here? Velocity of the sound wave in this pipe. N is nothing but what here? Frequency. Lambda is nothing but what here? Wavelength. So here I am taking V is equal to N into lambda 1. Especially general formula is V is equal to N lambda, but in this situation V is equal to N into lambda 1. V is nothing but what here? Velocity of sound in air. N means what here? Frequency. Frequency is nothing but what here? Fundamental frequency. Wavelength how much here? Lambda 1 is there. So V is equal to N into lambda 1. Therefore N is equal to how much here? N is equal to, from this equation, V by V by lambda 1. V is equal to N into lambda 1. Therefore N is equal to V by lambda 1. Therefore N is equal to how much here? V by lambda 1 value how much here? 4L. Therefore N is equal to V by 4L. So this is nothing but what here? Fundamental frequency expression. Okay, now fundamental expression. దీంట్లో మనకి 3 equations వస్తాయండి. Fundamental frequency or first harmonic, next third harmonic, next fifth harmonic. Okay, now for this pattern we will get 4 marks. Remaining 2 marks. 6 problem 2 marks. Total 8 marks. Okay, now so fundamental frequency means if the air column in the closed pipe is vibrating with at least one antinode and one node, then the frequency of the air column is called as fundamental frequency. If lambda 1 is the wavelength of the wave, then length of the pipe is equal to lambda 1 by 4. Why? Because antinode to node distance how much here? Lambda by 4. Therefore, lambda 1 is equal to 4n. But we know that V is equal to n into lambda 1. Therefore, n is equal to V by lambda 1. Therefore, n is equal to V by lambda 1 value how much here? 4n. So, what is the expression for fundamental frequency or first harmonic? In case of closed pipe, n is equal to V by 4n. So, first in the grand. So, simple derivation. So, diagram need to incident reflection. Antinode node. Velocity of sound in air. V value how much here? Velocity of sound in air, that is 330 meters per second. Here sound wave is passing through that pipe with some velocity, that is 330 meters per second. Over. Okay. So next one, same idea pattern, second bit. This is nothing but what here? Fundamental frequency or first harmonic, indicated with n. So n is equal to V by 4n. Next one, second one. This is third harmonic. Second one is nothing but what here? Third harmonic. Third harmonic. third harmonic. Third harmonic means what? N3. Fundamental frequency or first harmonic. And third harmonic means N3. ఇక్కడ ఏ నెంబర్ ఉంటే అది వస్తుంది అన్నట్టు. Here 3 is that is nothing but what here third harmonic. Okay na? Now in this situation, what is the diagram? In this situation, same pipe having same length L, different ఇది తీసుకోవద్దండి. ఇందాక ఎలా డ్రా చేస్తారు ఇప్పుడు కూడా అలానే ఉండాలి, సేమ్ లెంత్ ఉండాలి. ఓకేనా? సో L is the length of the pipe. In this arrangement, suppose if the air column is vibrating with like this, so here what happened? Here antinode is there, here node, here antinode, here node. So first wave traveling in this direction gets reflected at this other end. You get like this. So first wave traveling in this direction, reflected wave in this direction, superimpose with each other, then we will get a resultant wave is called nothing but what here? Stationary wave. Okay now in this situation, if the air column in the closed pipe vibrating with at least how many antinodes and how many nodes are there here? 2 antinodes and 2 nodes. Just number marchanante em ledhu ikkada. So here at least 2 antinodes. If the air column in the closed pipe vibrating with at least 2 antinodes and 2 nodes, then the frequency of the air column is called nothing but what here? Third harmonic. Called third harmonic. Okay na? Third harmonic. Now in this situation, wavelength. In first situation what happened? Wavelength of the wave is lambda 1. Here I am taking lambda 3. So if lambda 3 is the wavelength of the wave, frequency is N3, wavelength is nothing but what here? Lambda 3. Okay na? If lambda 3 is nothing but what here? Wavelength of this wave. Wavelength change avutundam. According to first harmonic and third harmonic, what happened? Frequency will change, at the same time wavelength will change. Okay, if lambda 3 is the wavelength of the wave, then length of the pipe is equal to how much? Length of the pipe is equal to how much here? Length of the pipe, that means antinode to node distance lambda by 4. Again node to antinode lambda by 4. Again antinode to node lambda by 4. So lambda by 4, lambda by 4, lambda by 4. That means lambda by 4 plus lambda by 4 plus 3 lambda by 4 we get. But in this situation, I am taking lambda 3. That means lambda 3 by 4 plus lambda 3 by 4 plus lambda 3 by 4. So L is equal to, what is the answer here? 3 lambda 3 by 4. Let expansion, no problem. Expand cheskondi, no problem. Length of the pipe L is equal to lambda 3 by 4 plus from here to here lambda 3 by 4. Again from here to here lambda 3 by 4. Again from here to here lambda 3 by 4. Okay na? So lambda 3 by 4 plus lambda 3 by 4 plus lambda 3 by 4. Lambda 3 by 4. Therefore L is equal to how much here? Totally 3 lambda 3 by 4. So from this equation, lambda 3 is equal to how much? Lambda 3 is equal to 4L by 3. Okay now? First harmonic what happened? Lambda 1 is there, but third harmonic lambda 3 is. So lambda 3 is equal to how much here? 4L by 3. Again, but we know that V is equal to N lambda. V is equal to N lambda, but N is nothing but what here? N3 into here lambda. V is equal to N3 into lambda 3. Therefore N3 is equal to how much? V by lambda 3. Therefore N3 is equal to V by lambda 3 is nothing but what here? Lambda 3 value 4L by 3. So 4L by 3 we will get. 4L by 3. Therefore, N3 is equal to, it can be written as 3V by 4L. N3 is equal to 3V by 4L. Therefore, it can be written as N3. N3 means what here? Third harmonic. Third harmonic means if the air column in the closed pipe is vibrating with at least 2 antinodes and 2 nodes. Okay, na? So N3 is equal to 3 into, but V by 4L is nothing but what here? V by 4L. That means fundamental frequency. V by 4L means what here? Fundamental frequency. So it can be written as N3 is equal to 3 into N. N3 is equal to how much here? 3 into N. Fundamental frequency N. Third harmonic 3N. Here we'll get 3. That's why this is known as third harmonic. That's simple. Fundamental frequency N is equal to V by 4L, but N3, third harmonic, is equal to how much? 3V by 4L, that is equal to 3N. Simple derivation, but also automatic మిగతా కూడా వచ్చేస్తుంది. First harmonic, third harmonic, next one, fifth harmonic, same pattern. Presentation important అమ్మా, ఏదో ఒకటి రాయడం కాదు, ఆర్డర్ మెయింటైన్ చేయాలి. ఈ ఓవర్ టోన్స్ ఇవి రాయొద్దు, ఎందుకంటే ఐబీ పాయింట్ ఆఫ్ వ్యూలో మళ్ళీ ఓవర్ టోన్స్ రాయడానికి జస్ట్ గ్రాస్ సరిపోతుంది. థర్డ్ హార్మోన్ రాయొచ్చు, ఫస్ట్ ఓవర్ టోన్ అని రాయొచ్చు, బట్ ఎందుకు ఎక్స్ట్రా మనకి థర్డ్ హార్మోనిక్ అయినా మెయిన్స్ పాయింట్ ఆఫ్ వ్యూ అయితే మనకి గుర్తుపెట్టు. ఓకేనా? ఫండమెంటల్ ఫ్రీక్వెన్సీ ఆర్ ఫస్ట్ హార్మోనిక్, సెకండ్ వన్ ఈస్ నథింగ్ బట్ వాట్ హియర్? థర్డ్ హార్మోనిక్. దట్స్ ఇట్, నో నీడ్ ఆఫ్ ఫస్ట్ ఓవర్ టోన్. ఎక్స్ట్రా పెంచొద్దు, మనం ఉన్న సైడింగ్ రాసేదాన్ని మనకి. ఓకేనా? మనం ఉన్నదాన్నే రెడ్యూస్ చేస్తున్నాం, మళ్ళీ మీరు ఇంకోటి యాడ్ చేస్తా అంటే ఎట్లా? రాసేది సార్ థర్డ్ హార్మోనిక్ అని రాస్తారు, మళ్ళీ దానికి ఇంకో నేమ్ రాయాల్సిన అవసరం లేదు. థర్డ్ హార్మోనిక్ అని. Yes, over. Okay. So next one, fifth harmonic. fifth harmonic, fifth harmonic, fifth harmonic, fifth harmonic, fifth harmonic. So third one is fifth harmonic. That means N5. So same pipe, same closed pipe. Okay. So in this arrangement, so here antinode, node, antinode, node, here antinode, node. Okay, now, so first wave is traveling in this direction. First wave. Next wave after reflection in this direction. Okay, now arrow marks were better and so first wave, second wave, reflected wave. Both are superimposed with each other. What happens? Stationary waves are produced. Okay. Now in this arrangement, if the air column in this closed pipe is vibrating with how many antinodes and how many nodes are formed here? 1, 2, 3. 3 antinodes. 1, 2, 3. 3 nodes are formed. In fundamental frequency, what happened? 1 antinode, 1 node. Third harmonic, 2 antinodes, 2 nodes. Fifth harmonic, 3 antinodes and 3 nodes. So that means if the air column in the closed pipe is vibrating with at least 3 antinodes and 3 nodes, equal number of nodes and equal number of antinodes formed. Okay, na? First one situation, what happened? 1 antinode, 1 node. Second one, 2 antinodes, 2 nodes. Third one, 3 antinodes, 3 nodes. So if the air column in the closed pipe is vibrating with at least 3 antinodes and 3 nodes, then the frequency of the air column is called fifth harmonic. Fifth harmonic. Now, here I am taking lambda 5. Lambda 5 is the wavelength of the wave. In this situation, in this arrangement, wavelength of the wave is lambda 5. Then length of the pipe is equal to how much here? From here to here, lambda by 4. 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 How many lambda by 4s are there? 1, 2, 3, 4, 5. 5 lambda by 4 is. Okay, now? So lambda 5 by 4, lambda 5 by 4, lambda 5 by 4 plus lambda 5 by 4 plus lambda 5 by 4. Okay. So length of the pipe is equal. Then length of the pipe L is equal to lambda 5 by 4. 5 was sorry. Lambda by 4, lambda by 4, lambda by 4, lambda by 4, lambda by 4. 5 lambda by 4 will get. So here I am taking wavelength lambda 5 is. So lambda 5 by 4 plus 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 1, 2, 3, 4, 5. Lambda 5 by 4. So finally, what is the answer here? 5 lambda 5 by Therefore, from this equation, lambda 5 is equal to how much? Lambda 5 is equal to 4L by 5. Lambda 5 is equal to 4L by 5. Lambda 5 is equal to 4L by 5. But we know that V is equal to N lambda. N means what here? N5. N5 into lambda 5. Therefore, lambda 5 is equal to, N5 is equal to, N5 is equal to V by lambda 5. Therefore, N5 is equal to V by lambda 5 is nothing but what here? 4L by 5. Therefore, N5 is equal to 5V by 4L. First frequency, first harmonic V by 4L. Second one 5V by 4L. Third 3V by 4L. Third one 5V by 4L. గుర్తుపెట్టుకోండి ఆర్డర్ ఫస్ట్ వన్ ఏమొచ్చింది మనకి n is equal to V by 4L. Second one n3 is equal to 3V by 4L. Third one n5 is equal to 5V by 4L. So it can be written as n5 is equal to 5. V by 4L is nothing but what here? N. Therefore n5 is equal to 5 n. Therefore n east, n3 east, n5 is equal to 1 east, 3 east, 5 east, so on. N east, 3 n east, 5 n is equal to how much? 1 east, 3 east, 5. Ratio of frequencies in case of closed pipe is equal to how much? 1 east, 3 east, 5, so on. రాసుకోండి. ఒకటే ప్యాటర్న్ ఉంటుందమ్మా ఇక్కడ. ఫస్ట్ అర్థమైందంటే ఆటోమేటిక్గా సెకండ్ వన్ సేమ్, థర్డ్ వన్ సేమ్. So n is to n3 is to n5 is equal to 1 is 3 is to 5, so on. Ratio of frequencies in closed pipe. సో నీట్గా ఒక దగ్గర రాసి పెట్టుకున్నాం, మళ్ళీ రేపు ఎగ్జామ్కి ఇవే చదవండి. ఈజీగా అనిపిస్తే మీరు చదవండి, లేదు నేను ఇంతకుముందు చదివింది ఈజీగా ఉందనుకుంటే చదవండి, నో ప్రాబ్లం. చాయిస్ ఈజీ వర్స్. ఆల్రెడీ ఇంతకుముందు చదివాము, అదే ఈజీగా ఉందంటే నో ప్రాబ్లం. మీకు ఏది ఈజీ అనిపిస్తే చదివాము. Yes. Over. మిగతా వాళ్ళకి ఏమైందమ్మా ఒక్కళ్ళే రెస్పాండ్ అవుతున్నారు 35013 మిగతా వాళ్ళు కూడా పెద్ద రెస్పాన్స్ ఇవ్వండి ఓకే సో బేస్డ్ ఆన్ దిస్ one problem is there so write on that problem long answer baby term ఇంతవరకు రాస్తే మీకు 6 మార్క్స్ వస్తాయి then problem formula answer 2 marks so write on that problem continuation of this నేను continuation లో రాస్తాను a closed argon pipe 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 70 centimeters long is sounded a closed argon pipe a closed argon ORGAN argon pipe 70 centimeter long is sounded if the velocity of sound is 331 meters per second if the velocity of sound is 331 meters per second what is the fundamental frequency of vibration of the air column what is the fundamental frequency of vibration of the air column what is the fundamental frequency of vibration of the air column so simple problem length of the pipe is equal to how much here length of the pipe L is equal to 70 centimeter length of the closed pipe is equal to how much 70 centimeters so convert into meters so 70 into 1 centimeter is equal to 10 power minus 2 meters చాలా మంది మిస్టేక్ చేస్తుంటారు డైరెక్ట్ 17 సబ్స్టిట్యూట్ చేస్తుంటారు సో సెంటీమీటర్ కన్వర్ట్ ఇంటూ మీటర్స్ ఓకేనా centimeters convert into meter that means 1 centimeter is equal to 10 power minus 2 meters okay velocity of sound in air is equal to how much v value given v is equal to how much 331 meters per second velocity of sound in air this is okay na 331 meters per second then what is the fundamental frequency this is nothing but what here fundamental frequency is equal to how much n value is equal to how much fundamental frequency for which pipe closed pipe so for closed pipe fundamental frequency formula n is equal to v by 4l for closed pipe fundamental frequency n is equal to v by 4l just substitute change so n is equal to v is nothing but what here 331 by 4 into l value 70 into 10 power minus 2 simplify చేసి చెప్పండి ఎంత వస్తుంది ఆన్సర్ ఇక్కడ so 331 into 10 power minus 2 here we'll get 10 square by 4 into 70 therefore n is equal to 331,000 by 28 therefore n is equal to 3310 by 28 what is the answer చెప్పడం ఎంత వస్తుంది ఆన్సర్ చెప్పాలి 11 మెంబర్స్ ఉన్నారు what is the answer ఆన్సర్ సెండ్ చేయండి అమ్మ ఒకసారి. 118.2 అంట. సో 118.2 hertz. SZ frequency units hertz and rand. HERTZ hertz. 118.2 hertz. సో ఫర్ ఫార్ములా విల్ గెట్ 1 మార్క్. ఇక్కడ మీరు గుర్తుపెట్టుకోవాల్సింది ఏంటంటే ఫర్ దిస్ ఫార్ములా విల్ గెట్ 1 మార్క్. n is equal to v by 4. మీరు ఇంత సింప్లిఫై చేస్తారనేది కాదు, ఇక్కడ ఫార్ములా 1 మార్క్. n is equal to v by 4l ఇది కనిపించాలి కంపల్సరీగా. n is equal to v by 4l కనిపిస్తే 1 మార్క్. నెక్స్ట్ ఫైనల్ ఆన్సర్ 1 మార్క్. n is equal to 118.2 hertz. This is for 1 mark. మీరు మధ్యలో సబ్స్టిట్యూట్ చేసి ఎన్ని స్టెప్స్ చేసిన అనవసరం. ఫార్ములా 1 మార్క్, ఫైనల్ ఆన్సర్ 1 మార్క్. సో టోటల్ 2 మార్క్స్. ఈ ప్యాటర్న్ ఎవరు చూడరు, సబ్స్టిట్యూషన్ అనేది. ఫార్ములా, ఫైనల్ ఆన్సర్. దట్స్ ఇట్. మీరు ఇక్కడ 100 స్టెప్స్ వేసి లాస్ట్లో నేను 130 అని రాశారు అనుకోండి, 1 మార్క్ పోతుంది. ఇంక్లూడింగ్ యూనిట్ రిజల్ట్ 1 మార్క్. చాలా మంది 118 అని రాస్తున్నారు అంతే. 118 అని కాదు, 118.2 హెర్ట్జ్ ఫ్రీక్వెన్సీ యూనిట్స్ హెర్ట్జ్. సో ఈరోజు ప్రాక్టీస్ చేయండి. కంప్లీట్ అయితే ఇమీడియట్లీ నాకు వాట్సాప్లో పోస్ట్ చేయండి ప్రాక్టీస్ చేసిన వాళ్ళు. ఎస్టర్డే క్వశ్చన్ ఇది 2, మళ్ళీ 2 ప్రాక్టీస్ చేయండి. ఓకేనా? లాస్ట్ వన్ వచ్చేసి ఏం చెప్పాం మనం, ఎక్స్ప్లెయిన్ స్టేట్ Kirchhoff's laws, state and explain Kirchhoff's laws, derive the balancing condition of heat from bridge, and second one is nothing but what here? Closed pipe. Explain the formation of stationary waves in closed pipe and derive the expression for frequencies. So ఈ రెండు ప్రాక్టీస్ చేయండి. ప్రాక్టీస్ చేసిన తర్వాత నాకు పోస్ట్ చేయండి. ఓకేనా? ఆ నెంబర్కి పోస్ట్ చేయండి, చూస్తాను. ఓకే, రైట్.